Welcome back, students. Hypothesis testing. That is a final topic that we have to study in the current SEM. So before passing on to the hypothesis testing, let's revise the certain terms that we have studied earlier. So these are the terms that you have studied in statistics: population, sample, statistical inference, etc. So population means that is all possible values. That is all possible values that we can get from a larger group. So if we just consider a pond ecosystem, and if we want to estimate the oxygen level of water present in the water, then we are not able to take the whole water from that pond, isn't it? We will be just taking the few sample of water from that pond, and that sample will be the representative of that whole population. So if this is a population, we will be just taking a small amount. This is a population and this is a sample. Okay, and we just use certain statistical inferences which shows that this particular sample is a representative of all the other samples which is present in this population, and for that we will be just calculating the certain degree of certainty, and that calculation is collectively called as a statistical inferences. We are just inferring that the property of this sample will be the same as that of the properties of the other samples present in that particular population. So we are just using certain calculation in order to get the result of the whole population. Okay, so by taking or by examining this small sample, we will be just getting the value of oxygen present in this particular sample, and we will be just calculating the certain uh, statistical inferences calculations will be doing, and we will be getting the values for the whole population. Okay, hope that idea is clear for you. Okay, then for a population we call the term as a parameter, and it is a mean value and it is represented by the letter mu, whereas the statistics, it's calculated from the data of the sample. For this particular sample, we'll be just using the mean, that is a x bar. Okay, so if you consider as a population, then you will be using the mu value, that is a population mean, and if you're taking the sample, then you will be taking the x bar value. So these are the statistical inferences that we are using. So that's only a revision. Then we will just pass on to the hypothesis testing. This hypothesis testing is also called as a significance testing. So the test a claim about a parameter using the evidence. That is, the data is a sample. We are just getting the certain data from a sample, and we will be using the certain test. For example, this is a test, t test, etc. And we will be just inferring the values of a particular population. And the procedure for the hypothesis testing is broken down into 4 different steps, and each element of the procedure we have to understand it very carefully. So the whole procedure of hypothesis testing is broken down into 4 different steps. The first, it is a stating the null and the alternative hypothesis. The second, it is a test statistics. The third, it is a p-value and interpretation. And the fourth, it is a significant level, and that is an optional level. So if it will be more scientific if we are using the significance level also. So in order to find out, or in order to test hypothesis, the hypothesis will be just stating the certain statements. So in short, What is the basic concept of hypothesis? Hypothesis, it is a tentative statement or prediction. It is a tentative statement or prediction or explanation of the relationship between the two or more variables. And or we can say that it's an assumption about a population parameter. So a parameter is a characteristic of a population, like its mean or the variance, and the parameter must be identified before it is analyzed. So anyone can assume the weight, isn't it? So he says that his weight is around 58 kg. So we can just prove his weight as 58 kg only after weighing him. Okay, so that is the statistical testing. Before measuring, he is just putting a statement. This statement is called as a hypothesis, and it can be proved. So after measuring his weight, we can just say that whether the statement is correct or wrong. Hope it is clear for you. So once again, the hypothesis, it is an assumption about a population parameter which is to be tested. So before undoing the test, we are just stating a statement. We are just giving a statement, and that statement can be true or false after testing it. For that, we collect the sample data, and when we calculate the sample statistics and then use this information to judge whether the hypothesized value of population parameter is correct or not. Okay, so you will be just collecting the data, you will be just doing the certain test, and you will be just confirming it whether it is correct or wrong. So to test the validity of the assumed or the hypothetical value of the population, we can gather the sample data and determine the difference between the hypothesized value and the actual value of the sample mean. So another example is that in mathematics, you might have proved the certain hypothesis, and the sum of the angles of a triangle is equal to 180 degree. And by using the certain procedures, you have just proved that it is 180 degree, isn't it? So that is another example for the hypothesis testing. And outside the field of maths, we are in other branches of science also, the hypothesis can be proved or disproved completely, and this hypothesis is called as a statistical hypothesis. And we can judge whether the difference is significant or not. That is a final step. Whether that difference is that you say that the given statement is wrong or the given value is wrong, and that difference is it is significant or not, that also you can determine. So the smaller the difference, the greater the likelihood that our hypothesis value for the mean is correct, and the larger the difference, the smaller is the likelihood. So if the difference is small, then we just accept it, and if it is a larger difference, then we will be just rejecting the hypothesis. So in hypothesis testing, the first step is to state the assumed or the hypothesized value of the population parameter. And this assumption we want to test, and it is called as a null hypothesis, and is represented by the letter H0. So in order to test the hypothesis, we will be just stating the two statements. Okay, the first statement, it is called as a null hypothesis. It is represented by the letter H0, and so the assumption to be tested, it is represented by the H0. And here in the first example that I have said, the average weight of the semester 2 student is about 58 kg, and this assumption is called, or this statement is called as a null hypothesis. And this hypothesis, we can just prove it correct or wrong after weighing, and after just weighing all the students and taking the mean. And the second state type of hypothesis, which is alternative hypothesis, it is represented by the letter H1, and this hypothesis, it is opposite to that of the null hypothesis. And this statement, it is the average weight of the student is not equal to 58. It is represented like this. H1, that is a alternative hypothesis. The mu, it is not equal to 58. The other one, it is a null hypothesis. H0, the mu is equal to 58. Okay, so this is the H0 statement, that is a null hypothesis, and this is the alternative hypothesis, that is a H1. So there are the two types of hypothesis, that is a null hypothesis and the alternative hypothesis. The next we can see the procedure for testing hypothesis. So the first, it is the setup a hypothesis, that is a making a formal statement. That is, you have to state the null hypothesis and also the alternative hypothesis. H0 and H1 you have to state it. That is a formal statement. So that is the first step in testing a hypothesis. So any statement that you can state depending upon the question that you have to answer. So the next step, it is a set up a suitable significance level. That is a confidence with which an experiment accepts or rejects the null hypothesis. That is a level of significance in the significant region. It is denoted by the letter alpha. So actually the hypothesis is tested on the predetermined level of significance and it is represented by the letter alpha, and is a commonly used level of significance. It is the 5% or the 1% level. The 5%, when we take the 5% level of significance, then the alpha is equal to 0.05. Then there are about the 5 chances out of the 100 that would reject the null hypothesis. That is what you mean. If you are taking the alpha as a 0.05, then there are the 5 chances out of the 100 that will reject the null hypothesis. Or in other words, we can say that out of the 100, it is 95% chances are there that the null hypothesis will be accepted. That is, we are about to 95% confident that we made the right decision. That is, we made about the 95% confident decision. That is, if you are taking the significant level as a 5%. Okay. Then this is a picture showing the normal distribution curve. So in the previous slide you have seen an acceptance region and the rejection region. This center region, it is acceptance region, and this, it is a critical region. So if you are plotting all the values in a graph and we are just getting a normal distribution curve, then the values which are coming in between these range areas is considered as a values which can be acceptable, and those values which are coming under this rejection region will be rejected. Okay, so that is the term that we call here, it is the rejection. Okay, so this is the rejection region. It is outside the confidence or the acceptance region. So outside the confidence or the acceptance region, it is a rejection region, and those values which are coming here will be rejected. Then if our sample statistics fall in the non-shaded region, that is acceptance region, then it simply means that there is no evidence to reject the null hypothesis, or in otherwise it proves that the null hypothesis is true, otherwise it will be rejected. Okay, so that's the statements, or that is about the selection of the significant level, and this level may be affected by the certain factors like the magnitude of the difference between the means, the size of the samples, variability of the measurements within the samples, and whether the hypothesis is directional or non-directional. So there are the certain exception cases also are there